We have two coordinates here. I'm going to just draw a rough sketch, not accurate or anything of what's going on. So I've got A here, 1, 5, and B here, 4, 17. And I'm trying to find the equation of a straight line which passes through 2, 8 and is perpendicular to AB. So I'm just going to draw a perpendicular line. And 2, 8 could be like anywhere really. Could be on the line, but let's assume it's not. So it's here. Okay, we need to give our answer in the form ax plus by equals c. So first thing is let's find the gradient of AB because that relates to the gradient of the perpendicular. And that is going to be y2 minus y1 over x2 minus x1. You could draw a little triangle and figure it out from that, but at this level it's just best to know that formula and then substitute straight in. So 17 minus 5 over 4 minus 1, which will be 12 over 3 or 4. Brilliant. And therefore, the gradient of the perpendicular, that's short for perpendicular, is going to be minus a quarter. It's a negative reciprocal. These two must necessarily multiply to give minus 1. And we're nearly there at that point. We can use y minus y1 equals mx minus x1. I highly recommend this equation just because you can immediately put your coordinates in. And for us, we're substituting, we've got the gradient as minus a quarter for this line. We've got the x is 2 and y is 8. So that's my x1 and y1. So y minus 8 is equal to minus a quarter times x minus 2. We could expand this out and everything, but actually best to just multiply through by, I think I'm going to multiply through by minus 4. So minus 4y plus 32 is equal to x minus 2. And then we're nearly there. Ax plus by equals c, so it's going to be x plus 4y is equal to 34. You could have minus x minus 4y is minus 34. You could even sort of have 2x plus 8y is 68, but it makes sense to just get rid of any common factors. You could even, I think, have fractions in your answer, but normally you try and avoid that. So here we go. This is the answer.